to help me pick how we use the next hour and a half, I asked you to watch a video for today. Who could tell me what the video included? What was in the video? Okay, adding stuff. What are the stuff that got added? What sort of stuff? Parameters. Parameters got added. Okay. And environment got added, so that people were located within an environment. And there were classes. Classes representing what, for example? Person. And there's a class associated with. Yeah, so there's a simulation-related class, so there's a class representing a scenario, and a class called main. Yeah. Good. So we saw some similar things in our discussion last time, and as I had to actually close AnyLogic, so I'll fire it up again, and I'd like you folks to fire up AnyLogic as well. Okay. So we saw how we could build a population out of agents, where each agent is described by a class. So if it's a person class, it describes personhood or personness, what it means to be a person with respect to the model. And we have many particular people, right, who can be situated at different locations, can be associated with different properties, different characteristics, and associated with different states that change over time. So that's good. We saw further how these individuals could be associated with an environment. The environment could situate them in space, for example. That's another aspect of heterogeneity, but it's one that's explicitly represented within AnyLogic. So individuals can have spatial locations, and as we'll see, those spatial locations can change over time. So an individual could move over time, for example, maybe be connected with other nearby individuals where the sets of individuals that change over time evolve, or the sets of individuals with whom a given individual is connected over time evolves as they move through space. So I'm in proximity with you two, and I'm in closer proximity to you, and over time, the people who are close to me evolve. We can have that sort of situation. So that's good. Within that model, we showed that there are ways of associating individuals with values for their properties that are different. So first of all, how did we represent a property of an individual? Sort of say their income or their age or their sex or what have you. Some characteristic of that individual. How do we represent it within a model? In AnyLogic, using a what? A parameter. So that parameter does two things. What two things does it do? Well, one thing is it encodes an assumption. The second thing is it's a mechanism, a means, a conduit for communicating that assumption to the agent from where? Who tells the agent what values the parameters to have? Who told it? Okay, so it's a characteristic of person that's being told. Maybe it's their income. Okay, maybe it's their income. It's a characteristic of that person, right? The particular. Now, if we consider a particular person, so that characteristic is defined in a class. It's part of their personhood is to have an income with respect to this model. The model's notion of person means that each person has an income. And each person, you consider a given person, Joe, who sets his particular income level? Where is that determined? Okay. It could be determined in the person class. More typically, though, it can be, but more typically, it's actually delegated to the population in which they're embedded. It's that population that has certain characteristics that associates them with a given value for their income. And different populations might have different distributions, for example, associated with income. One population might be a richer population, another population might be a poorer population. And all the people in that given population would have income drawn from the appropriate distributions. Okay. Where do those populations live, by and large, right now? They live in Maine, together with the environments there. But it's the broader, you could say informally, it's kind of the broader environment. They're situated in some environment. Okay. So, any questions you want to bring up about any of the things you heard? Questions? Things that are troubling you? Silence. Questions? Yeah. Yeah. Yes, we can have different environments. So different populations might be associated with different environments. You're saying, why do we need to reify the environment as an object? In other words, let's go take a look at this. I am going to, your folks are welcome to follow along, but I'm just going to create a really quick model here, and it'll be a little bit of a review. Okay, so here I do, a new model, and I will call it my first CMPT 858 model, right? Right? What's that? Okay, fine. Yeah, I was wondering if I should put that in there. Spring 2013. Okay. Oh, you're right. You're right. It is fall. Okay. And we'll just start creating a new model. Okay. So here we go, and here's our model, and in that model are created a main class. Okay, now we want to add a person class. We want to add a class of agents, more specifically. So we do new active object class. It turns out all agents are an active object, and main is an active object. And what that active object means is it indicates, for example, they can have a visualization associated with them. They can be run. They have some behavior associated with them. It has a bunch of other things. So they're all types of active object. Okay. So we're going to create it, and we're going to call person. And how do I turn it into an agent? Is that an agent right now? No. Yeah. Turn it into an agent. You gotta press agent. Kurt, you gotta help me nuggetize this. By stopping me at the right places here. Okay, so here's the person. Okay, so we now want a population of these persons. So we have a population. We have a person. Well, let's suppose we want to create a characteristic of the person. Characteristic of the person that will then induce some, on which we'll induce some heterogeneity. So maybe I'll call it income. I just drag parameter over into person, so I double click on person, make sure it's person canvas, and I drag parameter from this palette over there, and I'm going to call it their income, and it's going to be associated with a double precision value, right? Okay, now, how do I create a population of persons? First of all, where does a population of persons live? It lives in Maine. Okay, so let's go up to Maine, and how do I create a population of persons? I can actually do it with this thing, but it's I view it as actually a little bit easier to just drag person into here, and we'll call it population, okay? And you'll notice that down here there's a thing called replicated. And we want to select replicated, and we'll make it 100 of them, okay? What is that telling us? What does the 100 mean? Okay, 100 replicated agents that it will be in this model, right? Where is their income specified for each of those agents? Yeah, it's somewhat of a trick question. Is it specified right now? Not directly. Where could we specify it? Okay, so for this population, we could specify here, right? Okay, now I'm going to specify an income right now of 1,000 per person. Okay, let's hope it's per month. Okay, so well, it would be even better for per day, but let's suppose we say it's 1,000. Now, if we were to run this model, how do I run the model? Unless run, right? So it's building it, it's compiling it, in other words, and we have it here. And here's a population. There's actually 100 people there. We can go down and we can drill down here and we could see each person. But each person is singularly undistinguishing. And they all have a population of, or income of 1,000. Suppose we want to make their incomes different. Tell me what to do. Sorry? Click here. Good. Sorry? Add a formula. Yeah. So this is actually a Java formula here. It's a Java expression, this income. And you could actually give an arbitrary Java expression. This could do a function that computes, you know, the 100th prime number or whatever. It could do whatever. In this case, we're going to call a function, maybe it will be a log normal, something like that, a log normal distribution. Now, how did I get that up? I started, yeah, control space, yeah, okay, good. Now, you got to be careful here because AnyLogic normal and log normal in a fit of, I don't know what it is, it's really imprudent. They made the order of the parameters for log normal and normal opposite. So log normal takes a mean first and then a standard deviation, as one would expect. But normal takes it in the opposite order, which you got to be careful about. Okay, so log normal, I'm going to do a mean of a mu of 7 and a sigma of 3. Okay, and then I think it asks for a min and a max, if I'm not mistaken, or a min. And I'll have a minimum value of 0. Okay, now, what is this really meaning? So I give a value there. How is this actually used, ladies and gentlemen? It runs this expression for that individual. And in fact, if you look at this little thing here, it says use index of replicated person. What that's actually telling you is that in this expression, you can actually use the index of the person to get to know, okay, for whom am I getting their income? If it was the first person in the population, index would be 0. Second person, index would be 1. Third person index would be 2. So you can actually use that, you know, if you wanted to sort of say maybe we want the first half of the population to have no income and the second half to have very high income or something like that. But let's just do it this way for now, okay? So we have this log normal in there. So who's specifying that log normal? That's a property of this population in this case, okay? It's true that we could have the person directly impose it, but in this case, by default, it's sort of being given by the population. So I just ran that. So now I have this population, and I can go down and I can look at each person in the population, and they all have different incomes as drawn from that distribution. So some people, for example, are much wealthier than other people here. Ooh. Hey, refresh. Okay. So some people have income, you know, that are many times that of others. Okay. Okay. So that's good. So suppose now that Bahare was asking why is it that we have several environments? Like, why is environment reified as an object? Why is there an environment over here? That's what I understood your question to be. Kurt. Yeah, we could. If there would be interest in it, we could use AnyLogic 7 quite heavily, in fact. Yes. Yes, it is. I'll consider that. The question is it complete yet? I'll see if I can get an updated version that might have a few key features additionally put in. I'd like to also give something that's highly... It actually is very stable, too, which is decent. It's just that not all the features are fleshed out fully. So let me think about that. I like your idea a lot, young man. Yeah. Yeah. It would obviate the need for that. Yeah, exactly. Okay, good point. Okay, so Bahare was asking, why is it that we have this environment there? Why do we need this environment? So first of all, where would this environment come in? Can anyone tell me? Why is this environment used? Was that clear from the video? Maybe it wasn't clear. Okay, let's put it in. How they fit together, where they, it situates them. It situates them in space, and it situates them in terms of a network. Either one, or both, okay? So here's the environment. I've just dragged an environment in. Here we have this population, and you notice we could specify an environment. Aha. Notice that this is also an expression. Aha. So we can actually, pursuant to your question, Bahare, we could actually have different environments for different individuals. Some that dictate different layout in space or different layout in a network or what have you. Okay, so let's go specify the environment associated with the person, okay? And to see the characteristics of that environment, we can go to environment here, and you'll notice it's in continuous 2D, which is something we'll talk about later. So if we run this now, we could go look, and we'll see different individuals, but we can't really see their location. How would we see where they're located? Yeah, we have to place a representation on them visually. So to do that, let's go over to the right-hand side to this palette, and we go down to presentation. And for each person, well, let's do something more creative than was done in the video. Let's go down here and let's. What do you think? Okay, we'll make him a nurse. Okay, that's good. Okay, so we drag a nurse up there. I have a feeling some of the other people might be choosing other things like forklifts or something. Okay, so we just dragged the nurse up there. We gave them a presentation. Now, one of the things that's slightly confusing, if we go back to this here, and you go to the population, you notice there's a button that says Create Presentation. If we had actually added that in at first, before we dragged them into main, it would have known about their presentation. But since we've changed it, we actually have to press Create Presentation to update them. And then a nurse will appear. And that shows kind of where the origin is with respect to showing them, okay? So now let's run this simulation, and we can now actually see these people laid out. So these people will be at different locations here. Each will have a location, and we could scroll between these people, and we'll see each person, differs not only in terms of their income, but in terms of their location. Oh, come on. I don't know why this is frothing me. Forgive me just a second. Somehow it's telling me it can't get onto EduRoam. Okay. Okay, so in short, there we go. In short, we have no heterogeneity with respect to income for sure, but but heterogeneity with respect to location as well. Okay, so to answer Bahari's question, though, we could have multiple environments. We could associate different people with a different environment and therefore different, say, network structures or what have you. Does that make sense? Okay, great question. What other questions are there about this material? Okay, it's a good question. So their location, so agents means physical location. But it's mapped directly in this version of AnyLogic, not in 7, but in this version of AnyLogic, it's mapped directly into the virtual space that you can see. So why would we care about location? Why care about location? Okay. Yeah, so if you're located closer to someone, there might be a higher chance of transmission, right? So Kurt, for example, if I were to cough really badly, Kurt would probably be less likely to obtain it than would Sarah, for example. So it could be important for that. How about for other things? Well, to some degree, transmission of norms, actually, sort of who influences us. It's shown that people in nearby proximity have more of an influence on each other in terms of behavior than people at a distance. Okay? Sometimes communication, certain types of communication. After all, we're all here. If you folks were located across campus, you wouldn't. So for certain models, we care about location. For other models, we don't care about location. And we might have an environment, but we don't associate any semantics with location. We don't have location change anything. Let's put it this way. AnyLogic does, and I think this is maybe what Sarah's getting at. AnyLogic, so agent-based modeling platforms in general differ with respect to how fundamentally they assume location is within a model. Okay, so there's a platform called NetLogo where everything has to have a location. Whether you want it or not, it has a location. And that location almost always matters. AnyLogic is a little bit more relaxed than that. You don't have to worry about the layout. You could, for example, you could only use this environment to specify the network. So we could associate people in a network. And we could just say, we don't really care about location. All we care about is who their network, connections are, right? Yeah, they're friends.
Like
correct. Social networks. So we could say all we care about is that aspect of their context. We don't care about where they are particularly positioned. But in most models, whether you care about it or not, whether it matters for the behavior, whether it matters for the logic of the model, it's convenient to lay people out in space. Sort of show them it so they're not all on top of each other or something like that. It's kind of convenient, even if they're only in a network, it's kind of convenient to just have that network appear, laid out at some level. The location there doesn't matter in the sense of the logic of it, but it helps you visualize more easily what's going on. And so for a lot of models, the location doesn't matter for logic, but happens to be used for layout. Does that make sense? Yeah, so that's a great question. And it's a little bit subtle, so I appreciate you bringing it up. What other questions are people asking at this point? These are good questions. What other things are bothering you? We can specify it. So you'll notice that there's a layout type user defined here. If you go to person, so this is where Kurt was, I think, getting at. If you go to person and you go to agent here, you can see it says there's actually a delegation here to environment defines initial location. See that? For the person. If we wanted to specify their initial coordinates explicitly, like read it in from a database or calculate it or whatever, we could do so by overriding that and just specifying it here. But by default, we delegate it to the environment. But yeah, we could use whatever algorithm we wanted if we uncheck this and specify it here. Does that make sense? So we could specify Java code here that would say, you know, go and read it from some website or whatever, from a database or from an Excel file or whatever. Okay? So that's a good question. Excellent question. What other questions? This is what we're trying to use the class time to sort of answer questions. So who else has a question? Okay. You'd like to see what a network looks like. Okay. I would propose taking advantage of the luxury of this flipped classroom that we go and we do that manually. We go do it. Rather than, I mean, I could give you dozens of models where you could load it in right now, but I don't think you're interested. I think you're interested in seeing it, right? So should we do that? No, let's do it. Yeah. I think about 10 minutes we could get quite far, actually. Okay, you want to do it? Okay, so this is going to bring up some questions. Okay, 15 minutes probably. Okay, so ladies and gentlemen, here's our little model. Main, person. If anyone got lost, I added that parameter to person. And it's their income parameter, and then over in main, I added a population of person by dragging them up here. Had the environment. Remember, person had this dot here. Okay, so I'm going to stop this.